Which planet, besides Earth, is most habitable? Anyone who gives a definitive answer to this question is probably unreliable. To find the most habitable planet, you first need to know how to determine if a planet is habitable. Last time, from the perspective of similarity, we introduced an exoplanet, Kepler 452b. That is very similar to Earth. This planet is not only roughly the same size as Earth, but its parent star is also extremely similar to our Sun. Moreover, its orbital period is only 20 days longer than Earth's. Overall, it can be said that it is the most Earth-like exoplanet discovered to date. However, if we don't consider the star and only look at the planet itself, there are actually quite a few planets more Earth-like than Kepler 452b. Regarding the issue of Earth similarity, some scientists have even specifically proposed the concept of an Earth Similarity Index. This index is primarily calculated based on the planet's radius, density, surface temperature, and other combined parameters. Its range is between 0 and 1. Earth's value is 1. The closer the number is to 1, the more similar the planet is to Earth. It's important to note that this similarity index does not represent a planet's habitability, because the similarity index algorithm only considers a few major parameters, but there are many factors affecting a planet's habitability. For example, whether a planet has an atmosphere, what the atmosphere is composed of, what the stellar radiation it receives is like, and also whether the planet is tidally locked, if it has a magnetic field, if it has moons, and so on and so forth. In short, planetary habitability is a very complex issue, far from being determined by a few simple factors. Some planets appear to be roughly the same size as Earth, with a high degree of similarity, but in reality, they might not be habitable. Conversely, some planets, while appearing larger or smaller than Earth due to other more suitable aspects, may be more habitable even if their similarity index is not high. May be more habitable. To be honest, whether an exoplanet is habitable or not, at this stage, and for a long time to come, we cannot give a definitive answer. Although the similarity index does not represent habitability, considering that this value is calculated based on Earth, it still has some reference value for preliminary assessment of planetary habitability. For example, take Earth's neighbors, Venus and Mars. At first glance, Venus is clearly more Earth-like than Mars, but its similarity index is only 0.44. In contrast, Mars is much smaller than Earth, and also lacks an atmosphere, yet its similarity index is surprisingly 0.7. For most exoplanets, especially hot Jupiters very close to their stars, and distant ice giants, their similarity index is generally below 0.5, making them extremely uninhabitable. Only a small fraction of temperate rocky planets, including ocean planets, as well as some moons around Jupiter and Saturn in our solar system, can have a similarity index between 0.5 and 0.7. Currently, almost all planets with an index above 0.7 are exoplanets. That's right, the most Earth-like ones are actually outside our solar system. After all, Earth already occupies the most advantageous position in the solar system. For any other planet as habitable as Earth, we'll have to look around other stars. For example, Kepler 452b, which we introduced last time, has a similarity index of 0.83. It's 1,800 light years away from us. You might not imagine that Proxima Centauri b, the closest exoplanet to us, surprisingly has a similarity index of 0.86. It seems that as long as it's a rocky planet roughly the same size as Earth and located in or near the habitable zone, its similarity index won't be too low. So, how high is the similarity index of the exoplanet with the highest current score? It is Teegarden star b, confirmed in 2019. Its similarity index is as high as 0.95. Teegarden star b, as the name suggests, is the first planet we discovered around Teegarden star. Teegarden star is a red dwarf star only 12 light years away from us. This star is very small and very dim. So much so that even though it's only 12 light years away, it wasn't accidentally discovered in asteroid tracking data until 2003. Teegarden star has less than 1/10 the mass of the Sun. It even barely failed to ignite hydrogen fusion in its core and almost became a brown dwarf. Its size is even more exaggerated. As a star, it's surprisingly similar in size to Jupiter. Such a tiny star, its surface temperature can only reach over 2,000 degrees, and its luminosity is less than 100,000th that of the Sun. So much so that even if you put it inside our solar system, you wouldn't be able to see it with the naked eye. Because its spectrum is so faint, it barely covers the infrared band. For a star that can't even be seen, How were its planets discovered? Too dim. The transit method is definitely not an option. So we can only rely on the radial velocity method, which analyzes the Doppler shifts in a star's spectrum to determine if it has a slight wobble. If there's truly a planet nearby, the planet's gravity will have some effect on the star. This effect can be observed through the star's spectrum. Although the radial velocity method cannot directly see planets, its advantage is that it provides a relatively accurate calculation of the planet's mass. Astronomers calculated that Teegarden star B has a mass of 1.05 times that of Earth. Combining this with other data, they inferred its size should also be similar to Earth's. This means that the surface gravity of this planet is almost the same as Earth's. If humans ever manage to go there in the future, they won't have to worry about gravity adaptation issues. An interesting point is that Teegarden star is very close to the ecliptic plane, which is Earth's orbital plane around the Sun. Looking at us from Teegarden star, we would be in the transit zone for a considerable amount of time. This means that if there are Teegardenites on Teegarden star B, then from 2044 to 2496, for over 400 years, they would be able to observe the Earth transiting the Sun. So, will there be aliens on Teegarden star B? Although Teegarden star B's host star is an ultra-cool M-dwarf, this planet is located near the habitable zone. Generally, the smaller the star, the closer its habitable zone. So, this planet is very close to its star, meaning the stellar radiation it actually receives is no less than Earth's. The estimated surface temperature of the planet could be above 0 degrees Celsius, possibly even reaching 50 degrees Celsius. As mentioned earlier, a planet's atmosphere significantly affects its surface temperature. If the equilibrium temperature is already this high, and with the greenhouse effect of an atmosphere, wouldn't this just be another hellish Venus? Don't forget, this planet is extremely close to its star, only 0.025 astronomical units away. That's about 1/16 the distance from Mercury to the Sun. This means that, as a tidally locked planet, keeping its atmosphere intact so close to its star is a bit of a tall order. Astronomers estimate that Teegarden star B only has a 3% chance of having an atmosphere. While having no atmosphere doesn't sound like good news when it comes to surface temperature alone, it seems to be just right. Forget everything else. Just consider if the temperature is suitable. Since there's a suitable temperature, it's reasonable for water, the source of life, to exist on this planet. Astronomers estimate a 60% chance of liquid water existing here. If there's water, it's manageable. As long as there's enough water, even without an atmosphere, life still has a chance to survive. Yes, living at the bottom of the ocean. Because water itself can, to some extent, act like an atmosphere. It can block radiation and maintain temperature. Think about it. They're for thick gas-protected surface organisms. Now, it's the liquid in the ocean providing protection for underwater creatures. It's essentially the same idea. Although there is a suitable temperature and liquid water, there's still a critical issue for this planet. It's likely tidally locked to its star. Just as the moon is tidally locked to Earth, we only ever see the same side of the moon. The same applies to this planet. One side always faces the star, while the other is in perpetual darkness. For such a planet, with one half in perpetual day and the other in perpetual night, even if there's water, it might be trapped on the night side. Then the average temperature and liquid water mentioned earlier become meaningless. After all, one side is scorching hot, while the other is freezing cold. Is life only meant to huddle along the Terminator line? Through climate model analysis, scientists discovered that if its host star remains quiet for a sustained period, then this planet might form a small atmosphere. In this way, perhaps only 1/10 of Earth's atmosphere would be needed to establish a circulation mechanism on the planet, transferring the star's radiant heat from the day side to the night side. However, the lack of a magnetic field due to tidal locking might cause the hard-won atmosphere to be blown away by stellar winds. However, astronomers also found that Teegarden star's age should be over 8 billion years. It is no longer young and volatile. It is currently in a relatively quiet period. This, to some extent, also creates opportunities for life to emerge. All right, this is Let Me Tell You About the Universe. Talking about the universe in an easy-to-understand way. See you next time. Bye-bye.